way of getting at it. Okay, that's all we're going to talk about for this. Let's move on to looking at quantitative versus qualitative, or numerical versus categorical values. I assume that you're already familiar with this from the overview. But let's take a look at the homes data and try to determine which things are categorical and which are numerical. Generally speaking, it's a mistake to assume just because you see numbers that the data is numerical, and that if you see words that it's categorical. Sometimes it's not quite as straightforward as that. The way to look at this is based on what you want to use the data for. So if you're looking at a measure, or you want to measure something or look how much something is, then that kind of data will be used as numerical. If you're looking at how many things are, not necessarily a measure, but a count of how many things are in a particular group, like how many of this is, and that's the way you intend to use it, then that data is typically categorical. So once again, we're going to be looking at data. Depending on how it's used will determine whether it's numerical or categorical. Now, numerical, categorical, it's important to know which one is which, because we'll use different statistical techniques depending on what kind of data it is. So we typically start out by identifying how we want to use the data, whether it's numerical or categorical. There's some special cases like dummy variables, coded variables, and numerical bins, which we'll take a look at. So let's take a look at our data here. Now, we have already here on the left, we have home, and this is actually not even a variable. This is just a label. It's saying what record number is this? 1, 2, 3, 4. So this is home 1. That's the price, the bedroom, square foot, lot. So this is just a label for this related group of data for home 1. So we don't look at that. That's neither categorical nor numerical. Price is usually how much something is. We typically are using the price to talk about how much kinds of questions, and so typically price is going to be numerical because it's a measure. Now, bedrooms is the number of bedrooms, and you can see it's 1, 2, 3, 4, 5, 6, 7, and this is one of those cases that it depends on how you want to use this. It can be numerical or categorical. If I'm actually going to look at things like how many homes have more than 3 bedrooms, then I would consider this categorical data. I would want to group it into bedroom houses that have 1 bedroom, 2 bedrooms, 3 bedrooms, 4 bedrooms, and then just count how many are 3, 4, 5, 6, etc. If I'm looking at it in terms of what's sort of the average number of bedrooms, or the average number of bedrooms, I want to measure or look at the impact of the bedrooms on sales price, for example, like how does each additional bedroom change the sales price, then I might be looking at bedrooms as numerical data. So this is one of those cases where it could be either, depending on how you're using it. Square foot, generally speaking, it's a measure, and so we'll use it as a how much kind of thing, and so it's quantitative or numerical. Same with lot size. Age is, again, one of those ones that's a little different in terms of that it could be numerical or categorical, depending on how you want to use it. So if I want to look at sort of the relationship of the age of house to the impact on price, for example, I might be using this as numerical. But if I want to say how many houses are, say, 10 years or more, then I would be using it as categorical data. Again, bathrooms also might be numerical or categorical for the same sort of reason. If I want to look at the impact as a measure, then it would be numerical. If I want to look at how many houses have 2, 3, 4 bathrooms, then it's categorical. Now, CAC is our first example of a dummy variable. It stands for central air conditioning, and we code it with the number 1 if there's an air conditioner and 0 if not. Now, sometimes it's just done for convenience, but other times we use coding because for a dummy variable we may want to use it as a numerical value. In other words, if we want to understand what's the impact of having central air conditioning on selling price, then we might code up the air conditioner with the value 1 and 0 as not having an air conditioner, simply because I'm not interested when it doesn't have an air conditioner, and then I can use this as a way to pick out which houses have central air conditioning and understand what the impact would be on that. You'll see this when we talk about regression, that we can use a dummy variable as a numerical value for a categorical group. Now style, we see words here. Again, that's not necessarily meaning that it's going to be categorical, but since it's the style, it's really hard to see how you ever use this as a how much, as a measure of anything. So because we're not using it as a measure for anything, typically this is going to be categorical. Every house is going to be either tri-level, two-story, or ranch, and we tend to use it by counting how many are in each thing. That's how many are tri-level, how many are two-story. Garage, once again, can be numerical or categorical. I'll let you think about that. How many cars you could put in a garage here. Pool is another dummy variable, so again, numerical or categorical. View is an interesting one. This is a coded categorical variable. 1 meaning no view, 2 meaning view, 3 meaning good view. And in some sense, it's kind of numerical in the sense that there's an order. We certainly think that 3 is bigger or better than 2, which is bigger and better than 1. And we might be interested in the impact of a view on price, for example, and in that case we may be able to use it as numerical, but we have to be very careful on how we use it. It wouldn't make sense to talk about the average view. Like if we look at the view, if we look at the average of all these things, let's just try that here. I get 2.30555, whatever. So what would that mean? What would an average view of 2.305 mean? How would I interpret that? Is that more like a superior view, or is that more like just a good view, or that there is a view? I don't know. And people run into trouble with coded ordinal values, especially in surveys like Likert scales, where you usually pick a value between sort of strongly disagree to strongly agree, and you might code them as minus or 1 to 5, say, for example. And the problem with that is, like, if you look at an average value, it's difficult to say how much that is towards one category versus another category. So you have to be very careful. Typically this is abused quite a lot. So if you're counting how many are in each, that's okay. But if you're going to take things like averages and use these as sort of measures and things like that, you have to be much more cautious. So often coding like this with a 1, 2, and 3 is just done for convenience, not usually to make it use of it as a numerical value, like with the dummy variables, which you can use. School administrative district is probably going to be categorical because, again, we're going to be in school district 1, 2, or 3. We usually just want to know how many, and I can't imagine using this as a measure of any sort. So you can see it can be a little tricky. The last thing you want to talk about in terms of numerical versus categorical is numerical bins. So just like categorical variables sometimes could masquerade themselves as numerical variables and maybe even be used as numerical variables, sometimes numerical variables might be masquerading as categorical variables. So for example, if I look at selling prices of homes, I might group them into things that are under 400,000, between 400,000 and 900,000, and greater than 900,000. And I might call one low, mid, and high range prices, selling prices. Now, in this case, I might be using this data as categorical in terms of counting how many lows, how many mids, how many highs. And that's fine as long as you're very careful about defining what these ranges are, and that you say what those ranges are. But often they're used carelessly, because these are actually numerical, based on numerical data. If you convert these to these categories, they may become difficult to interpret or even misleading. So for example, I might say more than 50% of the homes have mid to high selling price. Well, if I'm not real clear on why I chose 400,000 to 900,000 and greater than 900,000 for mid to high, it's not very clear what this means. I mean, I could have chosen whatever ranges I wanted for low, mid, and high to suit whatever ranges to make this statement is meaningful or meaningless or misleading as I like. So you have to be quite careful. Numerical data, in this case, this is actually categorical data that's sort of hiding as categorical data. For more details, you can look at the rules of thumb for determining data types, which may be helpful in tricky cases. And I'm just taking a look at this now, and you can see just basic ways of trying to help you identify. Generally speaking, it's very important to identify what kind of data type it is the very first thing you do. So let's say we've determined our data type